Okay, so what I'd like you to do, if you haven't already, is get your homework out from yesterday. I want to go over it. I gave you guys 2 sets of questions. This is the first set. The first page just wanted you to identify acids, bases, salts. Here are my answers. Block D is better at catching my mistakes than you guys, and they didn't catch any. They caught mistakes yesterday that you guys missed when I gave you answers to the homework from the day before. You guys are just not as good at catching my mistakes. You have more, or maybe you have more faith in me than they do. I don't know. You shouldn't. Mistake, that's it right there. If Josiah did the work, maybe he'd catch my mistakes. You should start again. Well, the videos are up. So let's get you back to where you need to be. Yes. Letter I. That guy there? Na3PO4. No H, no OH. So it can't be an acid or a base. Has to be a salt. M. Ooh, this was the secret acid, the screwy acid that you need to remember. That H is out back in CH3COOH. That's always, that H out back is an acid. That's the one acid you got to remember. No. When there's an H, acids, OH is a base, OH is a base, OH is a base, OH is a base. This one, I've said it a bunch of times now, this is the one exception. CH3COO, that's the polyatomic ion acetate. And for some reason, when you add a hydrogen to acetate, it's acetic acid, that's vinegar. But instead of putting the H out front, they put the H out back. I don't know why they do that. That's the one you need to remember. The CH3COO is always going to be an acid. Imparis. What about number N? Yeah, what about N? That's Mg. That's CH3COO. There's no H, there's no OH. No, that's a polyatomic ion acetate. You can't rip apart the polyatomic ion to be like, there's the hydrogen, go get it. It doesn't work that way. That's a salt. Pun intended. See, Malik was away and I didn't post the video, so cut him some slack. Okay. Anybody else? Comments, questions, concerns? Anything off that page? Going once, twice, thrice, sold to Angel. Okay, the next piece was this. I told you I wanted you to complete all, but only balance letters A, C, E, and G. For those of you who maybe went a little bit overboard, I balanced all of them because really it's not that hard. So you can, if you did more than you were supposed to, there they are. You needed to remember that when you react an acid and a base, the first product is always water, and then the second product is made from the leftover components. So the salt is going to be, in this case, the Na and the SO4, and you have to build it properly using the charges on Na and the charges on SO4. Let's go zoom this in a little bit so it's easier to see on the screen. And then I went ahead, like I said, I went ahead and balanced them all. Comments, questions, concerns? Going once, twice, thrice, sold. Okay, cool. So there's no questions on the top one. We're good with the balancing. We're good with building salts. Malik, stop talking to the girls. And so see, because Malik, you were away, so I really want you paying attention. And your friends aren't doing you any favors. Okay, no questions, comments, concerns? Okay, then here was this one. The way to do these kinds of questions, it started with the words and the question. I told you didn't have to balance, but I did want you to include both the word equation and the formula equation, or the skeleton equation. So from the words, I built the formulas, and then I built the salts and the water, and then I went back and I gave the names. That's the way to do this kind of question. You go from the acid-base names to the acid-base formulas to the water and salt formulas up to the water and salt names. That's how you tackle questions like this. You did not have to balance. Comments, questions, concerns on anything I did there. According to D Block, my work was correct. That doesn't mean that it is. That just means they didn't catch any mistakes. Me too. I'm with you. Not that I don't enjoy teaching. I really do. But I'm really tired today. Okay. If there are no questions, let us move on. I'd like you to flip ahead. I'd like you to find, where's the page? Where's the page? This page. Boom. Find me this. Okay, stop. Too much communication is happening here. Too much. Stop talking. Okay, here we go. So, yesterday, I introduced to you, without really formalizing it, what we did yesterday is what we're going to do today for a bunch of different chemical reactions. One of the most important skills to develop in science and really in life is the ability to identify important information. Identify information. So what am I trying to tell you by providing you with a certain set of information? And make predictions based on that information. Predictions. So much of life is identifying info, making predictions based on what you see. And if you don't do this or can't do this, your life will be infinitely more difficult as a result. Especially for any of you who hope to ever one day be in a relationship of any kind. To be able to take in what you're seeing and predict what's going on without having to open your mouth and ask a silly question is important. So, in chemistry, as in life, chemists must be able to identify what they have and predict what will happen when certain chemicals are reacted. So this gets done in a whole bunch of areas in science, and sometimes it gets done really, really well, and sometimes it does not get done very well. For example, when nuclear physics was first becoming a thing, you have to test them somehow. If I take this and I'm like, oh, okay, this should do this, and then you make it do the thing, and when you test nuclear reactions, what do you get every time? A nuclear blast. When you're testing explosions or explosive things for the first time, predictions are important. And problems go both ways. There was one atomic bomb that they built, and they did the math, and they're like, okay, based on the math, it should only be this big. They detonated it, and it was about 10 times larger than it was supposed to be. They oopsed. There was another bomb that they were testing, another nuclear reaction. They're like, what's going to happen here? And they're like, if our math is correct, we could incinerate the atmosphere, killing all life on Earth. Let's test. Yeah. Obviously, they didn't. But there was fear at the beginning that we're just going to ignite the atmosphere. Why would you do that? Because you only screw that up once. There's no atmosphere in outer space. How do you test that in outer space? No, the missiles weren't around for that yet. We made the bombs before we made the missiles. That was so much of, you need to do some World War II history. The bombs came first, the missiles came second. There's nowhere else to get it to space. So, predictions are important. There are 6 main reaction types that we are going to look at. These are 6 of the most fundamental reactions in all of chemistry. Some of the really big chemical reactions that happen are just multiple versions of these guys happening at the same time. So these are the 6 that we look at. Yes, Angel. Yes. We are going to talk about all 6. I am going to demonstrate all 6, and then you guys are going to do all 6 yourself. I have the lab booked for Friday and Monday.
Are we doing it Friday and Monday?
We're going to do the theory today. I am going to do the demos tomorrow. And then we will do the lab on, wait, today's Wednesday? The lab Friday, Monday. Or maybe Monday, Tuesday. Elephant toothpaste? I'm doing that demo. I'm doing the demo. Yeah. In class. Yeah. Sorry, what? No. I'm demoing things that are different than what you're doing. Elephant toothpaste actually uses one of the most dangerous compounds we have in our little room, so I'm not letting you do that. No, today I'm not demoing. You're leaving in 5 minutes. You're not going to miss any demos today. Okay, here we go. So I don't know if the lab is Friday or Monday. I've booked it both days. I hope to do Friday. It might be Monday. It'll probably be Monday. Here we go. So there are 6 main types of reactions: synthesis, decomposition, single replacement, double replacement, acid-base neutralization, and combustion. These are the names. Oh, they're all pretty cool. They're all pretty cool. Well, I'm going to demo them all for you, and you can tell me which one you think is the coolest. Yeah, I used to think combustion, but now I think decomposition. Wait, no. Single replacement is my new favorite. I'll show you. Not today. Here we go. So, no, why would I tell you something to Google before I have the chance to do it for you in person? I'm not telling you. No. Okay, sure. It makes this. It's not concrete. This is iron. This is pure iron mixed with sand because I melted it together. We're going to make molten iron. It's going to be awesome. Obviously that one gets done outside, and you guys have to stay about 10 meters back. But yeah, it's going to be great. Yeah, you got to stay. Yeah, because sparks will fly. And I tripled the size of the reaction that I did last year for you guys for this year to make it cooler. So, it was pretty cool last year, but I made it 3 times bigger. So it's going to be great. No, I'm going to talk. No, stop. Okay, here we go. So, synthesis is the first. First, we're going to do a lesson on etymology. Not entomology, the study of bugs. Etymology, the study of words. When I say the word synthesis, what comes to mind? Photosynthesis. That's the first thing the other block said too. What is photosynthesis? Someone describe it to me. Okay, cows go. What does that mean? Number it. What's cows go? Carbon dioxide.
Yeah, and water and sunshine.
Water and sunshine becomes into oxygen and glucose. Carbohydrates. That is photosynthesis. The reason we call it photosynthesis is because light gets used to make something new. When you synthesize something, you are creating something new. And so a synthesis reaction is going to take a couple products and it's going to make something new. And you might say to yourself, well, don't all of these chemical reactions make something new? Yes, but not like this. It's special into of itself. Okay, synthesis, creating something new. Photosynthesis is a fantastic example. The word means light making something new. Decomposition, what is that? What do you think of when you think of that word decomposition? Also the same thing D Block said. Composting. What is another word for, what is happening when you compost? Don't say decomposition. Something is rotting. What is another set of two words that we use to mean something has rotten? Two words, B and then D. No. Broken down. The process of decomposition is the process of breaking down. No, B is the first word. D is the second one. B and D. Yeah, because I said, oh yeah, you heard the wrong thing. Maybe I wasn't clear. Decomposition is breaking something down. So a decomposition reaction is going to do exactly that. It's going to take something big and complicated, and it's going to break it down into the pieces that make it. Easy, nice and easy. Single replacement. Based on those two words, what do you expect this reaction type to do? Based on the words single replacement, what do you expect this reaction to do? One thing is going to replace one other thing in something that's more complicated. It's the distracted boyfriend meme. I get a lot of mileage out of that meme every year. It's the distracted boyfriend meme. You have a couple. They're walking down the road. Another singleton walks by. That singleton is going to replace the appropriate part of the couple. The single replacement is the distracted meme. And according to The Office, the TV show, that's okay, because dating ain't married. What? I didn't call it cheating. I said according to The Office, just because you're dating doesn't mean you're married. No, I said according to The Office.
Yeah, I know what you said.
Okay. Shoot your shot. You gotta go. Okay. Double replacement. Go ahead. What does that phrase lead you to believe is going to happen?
Two things replace two other things. No,
Yeah.
one thing. Two things replace one thing.
One thing replaces two things, two and two, one and one. Two and one.
Okay, so in a double replacement, two things are going to swap spots. Enjoy the dentist. Watch the video, it'll be up. Okay, double replacement is going to be a lot like single replacement. Two things are going to swap spots. Acid-base neutralization. We've done this one already. You take an acid, you take a base, you make water and a salt. That's what we did yesterday. If you were away yesterday, I'm sorry I didn't post the video. It'll go up today after school. And then a combustion. Combustion used to be my favorite. You asked my opinion. Combustions used to be, yes, because when you think of a combustion, what do you think of? Boom. An explosion. But we have to be more specific here. Not every explosion is a combustion, and not every combustion explodes. When we're talking about a combustion reaction, we're thinking about a specific kind of explosion, or controlled burn, as the case may be. What? Sorry? Air with what? And it's not, no. Because air doesn't just go with fire on its own. And it's not even the air. What is it in the air that is required for a combustion reaction? Nope. Oxygen. It's not hydrogen. Hydrogen on its own will explode. But it in itself is not a combustion. Hydrogen does not combust on its own, because you need something else to involve the combustion. And There's a whole class of compounds that can go in here. When you think of what is the one thing that gets labeled as a combustion that you are most familiar with? When you think of combustion, what do you think of, Vikram? Gasoline, where? Well, hopefully it's not happening at the gas station. In the car. The internal combustion engine requires either gasoline or diesel. Okay? Okay? No, diesel is not. Get more careful than that. Gasoline and diesel are examples of things involved in combustions. There's another one. There's a combustion reaction that perhaps you do at home in your barbecue. For those of you who eat meat or like to roast your vegetables. In a barbecue, that is a controlled combustion reaction. Propane burning is a combustion reaction, but it's not an explosion. Not every combustion reaction is an explosion. Can you make propane explode? You bet you can, but it's not always an explosion. You will destroy your engine. You will need a full engine rebuild. No, it doesn't explode. It will not successfully combust. You will wreck your engine. Less of an issue, still not great. It depends what is different about the oil. The oil is just there as a lubricant. The oil is not burning. So if you don't use the right lubricant, you're getting me off topic. It's different. Putting the wrong fuel is worse than putting in the wrong lubricant. Still not great. Not as bad. Okay, so those are the 6 based on their names. So the reason I want to go through this little bit on using the names properly is because I am going to give you reactions, and I'm going to say, I want you to label which one is the synthesis, which one's the decomposition. You're going to mix up a whole bunch of these things, and you got to figure out what's what. Using the names should give you a clue as to what kind of reaction is present. If you can be like, okay, I know what a synthesis is. A synthesis is the creation of something new. A decomposition is the breaking down of something big. A single replacement means I need something alone and something together. A double replacement means I need 2 things that swap. An acid and base means I need an acid and a base. If you can identify these things based just on their names, it'll take you a long way. So let's go through them in order of, well, the order I've given them to you in, and look at specific examples of each type. We're not going to get this done today, probably. We'll probably get about halfway through. Let's take a look. First one, synthesis. Synthesis reactions are single elements or ions combining. I spelled that wrong. I-N-I-N-G. Combining. That looks gross now that I screwed that up. You know what? I'm going to rewrite that. That's gross. I know. It doesn't say onions. Or ions. Single elements or ions. I know I can see how that R would look like an N. Single elements or ions combining. There we go. To produce a compound. That is our definition here for a synthesis reaction. I am going to give you, for each one of these, I'm going to give you a definition, and I'm going to give you a general form of what these things look like. The general form is going to look something like this. If I have a single element or a single ion, I don't know what they are. Let's just call them A and B. Element A is going to react with element B, and it's going to produce something. It's going to produce a compound. The simplest compound I can create for you using the letters A and B is the compound AB. That is a synthesis reaction. 2 singletons came together, made something more complicated. In this case, a compound. So I got a couple examples. Here's two. Magnesium metal reacts with oxygen gas to form magnesium oxide. Okay, well, let's do this. What is the chemical formula for magnesium? Mg. It's going to react with oxygen gas. What's the chemical formula for oxygen gas?
O.
It is not O.
2O2.
It's O2 because oxygen is diatomic. If you recall, the diatomics are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They make a 7 in the top right-hand corner of the end of this hockey stick and puck, up in the top right-hand corner of your periodic table. You need to be on the lookout for, beware of the diatomics. I'm not going to tell you which ones are which. You need to figure that out.
So let's just say instead of oxygen, would it be just the O then?
Nope.
It'd still be
Oxygen on its own will always be O2. No, when it's with something, you have to balance charges. So, correct. So, these two are going to react to form magnesium oxide. You have actually seen magnesium oxide because in the acid-base lab I gave you before spring break that some of you finished on Monday, you took magnesium strips, you put them in 4 different compounds, and the magnesium all had like little gray stripes on it. It wasn't pure smooth silver. And that's because on top of that magnesium, you got magnesium oxide rust is effectively what happened there. So how do we make magnesium oxide? To build the compound, we need to balance the charges. So let's go ahead and do that. Magnesium is going to be Mg. What's the charge on magnesium? Positive 2. What's the charge on oxygen? It's negative. It's negative 2. Some of you need to have your periodic tables at the ready for this block. So when I take Mg, charge of plus 2, and I take oxygen, charge of negative 2, when these guys form a compound, what's the compound?
MG.
It's MgO. You swap, drop, and reduce. Okay? So this thing is unbalanced, but this is the correct skeleton equation. That's an example of a synthesis reaction. I took 2 elements, I combined them, I got a compound. Next one. Nitrogen gas can react with oxygen gas to form dinitrogen monoxide, also called nitrous oxide, also called NOS. We put this as a fuel additive, makes cars go boom faster. What movie series abuses Fast and Furious? But nitrous oxide has another name. It's not just a fuel additive for cars. It also has a medical application because when you inhale nitrous oxide, it makes you euphoric. You stop caring about what you're feeling and everything becomes funny. We call it laughing gas. NOS, nitrous oxide, gets used in 2 places primarily. The dentist office, when they don't feel like putting you under, as an alternative to pain medication, and, ladies, during childbirth. The first, that is a last resort. That is like the most, I learned all about this. An epidural? An epidural, there's pros and cons to everything. So, for example, my wife did not have time for anything other than nitrous oxide when she gave birth to our son Jack, because she went into labor at 6:30 and he was born at 7:30. The whole process happened so fast.
Was she still like laughing?
There was no time for anything else. The pain is there. The pain is there. You just don't care about it. You're high on this nitrous oxide and you just don't care about the fact that you're in agony. You asked about an epidural? An epidural knocks out all feeling below where it's placed. So you put an epidural in, there's pros and cons. You won't feel, the needle goes in your spine, you feel nothing below that point. The dangerous part of an epidural, for those of you, pro tip, everyone who's considering having a child, the dangerous part of an epidural is, Angel, you actually losing all feeling below, you need to push the baby out of your body. You lose the sensation of what it feels like to push out that baby. So an epidural can be dangerous because you can not know then when to push because you don't feel the contractions. You feel nothing below where that needle goes in. So it can make actually delivering the baby take longer and be harder because you don't know when to push. I have had friends who swear by epidurals. My wife didn't have an epidural for either of our children, and she survived. So there, informed consent. So nitrous oxide is created through the reaction of oxygen gas and nitrogen gas. Let's do the chemical reaction. Nitrogen gas has what formula? It's N2. Nitrogen is one of the diatomics. It reacts with oxygen gas. The formula for oxygen gas is O2. Cool, pause. I'm so glad you asked that question. That question is irrelevant because nitrogen and oxygen are both negatively charged ions, and so you can't balance charges when they're both negatively charged. You have to use the name. They form dinitrogen monoxide. So what's the formula for dinitrogen monoxide? N2O. The di on the nitrogen tells you that there's two. The mono on the oxide tells you there's one. There it is. N2 plus O2 reacts to produce N2O. That's laughing gas, or NOS, depending on where you're using it. Either in your car, the dentist office, or the delivery room. And I can assure you it's effective. Okay. I want you to do those 5 questions right there on your market set, go. Can you, these 5 first. On your market set, go. I want you to create the products for those 5 synthesis reactions using ion charge balance. Okay, how do I do this? I want you to synthesize these reactions. You all need your periodic table. This is better. You know what? I'm going to be a picture of a good one.
I was doing something. Yeah, you're probably
Just because I didn't notice the infraction doesn't mean your infraction okay. Okay, create for me the products. Your markets, go. You got to balance the charges, build them properly. Yes, sir.
I don't know.
Say all up 3 guys. I don't know. There. But you don't have to balance it. What about create? I still haven't seen anything. Okay. I want you to do those 5 first.
I don't know, bro. I don't know.
Yes. That is not correct. You don't need the extra bracket. No. When you're building these things, you're just using the charges on each. So magnesium is +2, the nitrogen is +3, sorry, -3. So this would just be Mg3 N2. It's not N2. Sorry. No, this is something that's nothing to do with what you're building. You just all you consider is the charges.
I don't have like that.
No, I gave you the one side already. Give me the other side. And the metals don't make diatomics. Let me check first. Where are you heading? Oh, you can go there? Yes. Okay, gentlemen, you can move over, which is actually going to be productive. Can't move over, no problem.
You guys get
You don't have to bounce this one. Yeah, good job. Yep, go ahead. Okay.
Why don't you do it?
Oh, okay, put the balloon away and I'll leave. I don't know, put it away. No, don't pop it. It's a balloon. Anyone's gonna pop it, it's gonna be me, number 3. No. Good, but I said, no. First yeah, 1D. No. No. No balloons. No balloons. Okay, let's take a look. Okay, so the first one. If you build them properly, you're balancing charges. The first one you should get when you combine magnesium and nitrogen is Mg3N2. The charge on magnesium is 2, the charge on nitrogen is -3. You swap and draw. Letter B, aluminum has a charge of +3. Fluorine has a charge of -1. So it's going to be, you betcha, AlF3. AlF3, you betcha. The next one's going to be K2O. The next one's going to be CDI2. And the last one is going to be CS3P. Comments, questions, concerns on any of those? Soham, we good? Okay, cool. Next one, those are synthesis reactions. First type. Second type, decomposition. Let's go. Decomposition. To decompose things, you are breaking them down. So, here's our definition, and we'll go through our general example. A compound breaks down into individual pieces. Okay. So the general example that I can give you for this is compound AB. Is going to break down into what? It's not going to be AB. A plus B. Now, A and B don't have to be individual elements. They could be polyatomic ions. But to identify a decomposition reaction, you're looking for a single large compound breaking down into smaller bits. I have two examples here. I've written them out for you already. Two examples are this. You can decompose table salt by electrolysizing it, running an electric current through it. If you do that, you're going to make sodium metal and chlorine gas. Do not do this at home, because chlorine gas is poisonous and sodium is explosive.
Like, what happened when you say gal?
Can you die?
They used it as a weapon in World War I, yeah. It's a green gas. It's heavier than air. It rolls along the ground, and it will burn you from the inside out. It will kill you. They used it in trench warfare in World War I, yes. Okay? So you've got a larger compound, gentlemen in the front and in the back. Okay, Josiah, Nimbaris, you've got a large compound that breaks down into two smaller bits, the sodium and the chlorine. That's one example. Again, always beware of the polyatomics. Atomics and diatomics. Another example that you're familiar with, Soham, I'd like you to put on your desk what you just brought back from the vending machine. Yeah, actually hold it above your head for all to see. That, what Soham has just done, is an example of this reaction right here. In that Dr. Pepper, in that soft drink, under pressure, carbonic acid was present. While he was walking back from the vending machine, Soham cracked the cap on that thing, producing a bunch of bubbles, presumably. The bubbles were CO2. And what was left in the carbonic acid was H2O. This is what makes pop flat. So if Soham were to take the cap off that, we let it sit there for a while, the Dr. Pepper would not be as Dr. Peppery as it was. It would be better because Dr. Pepper is gross. But it would become watery. It'd become flat. And the CO2 is the bubbles. That is a decomposition reaction that happens for some of you every day, far too often, every time you consume a carbonated beverage. So what I'd like you to do now is flip the page. There are 5. I would like you to make the decomposition products for all 5 of those reactions on your market set go. You betcha. What are the decomposition products for those 5 reactions?
Do we just put the, like, if you're looking at AuCl, AuCl?
It would be A almost. It's not Au plus Cl because chlorine is diatomic. It would be Au plus Cl2.
Okay. But if it wasn't diatomic, it would just be Cl?
Yes. So the second one, sorry, Josiah, what did you get for the second one? In this case, in these examples, yes. Because chlorine, oxygen, fluorine, nitrogen, and iodine are all diatomic. Correct. Only the diatomic ones you put 2s on. It's one of the 7. Look at the table. It's that 7 in the top right-hand corner. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. and hydrogen. Sorry? You bet. Okay, these first five, or these, they're not first five, these only five, should all, like decomposition is the quickest one to do. You should get results look like that. Comments, questions, concerns on anything I've done?
No.
Okay. Okay, if there are no questions, let's talk about the third one. The third one now is where we actually start having to do a little bit more work.
No.
Yeah, work sucks. Boo. Single replacement. Actually, work is good. It builds character, helps you learn stuff. Here we go. A single replacement reaction. Here is the definition. An atom slash ion, right? Small, I didn't leave a lot of space. Reacts with a compound and replaces one of the elements. And we're going to have to figure out which one. So, the simplest general example I could give you for this is our atom or ion is going to be A, plus the compound, which is going to be, B is not a compound.
Maybe.
Well, I already have A.
BC.
BC, there you go. And now we've got to figure out what is A going to replace? Why B? Why C? You need to have a good, valid reason for this. Okay, so let's take us back to the very beginning of chemistry this year. You did it also in grade 9. When we list BC, there is implied assumptions made about B and C. When I list them in this order, what does that tell you about B and C? B, you can think of it that way. B is a metal, C is a non-metal. When you list them, the metal always comes first, the non-metal comes second. The other way to think about it? Okay, metal, non-metal. The other way, positive and negative. The first thing listed is always going to be positive. The second thing listed is always negative. And so which one A replaces is going to depend on what about A? Liam, what were you going to say? The charge on A, is it positive or negative? So there's two options here. It's like it's not a choose your own adventure, but it's like a choose your own adventure. If A is positive, what is A going to swap with? A will swap with B. So B will go off on its own, and A will take B's spot, creating compound AC. The two positives will swap spots. B gets booted, A goes where B was. But if A is negative, it's going to swap with C. C plus BA. Depending on the charge of A, it will replace either B or C. So I'll do one example, and then you're going to practice 5. Here's your example. Aluminum, and you are going to, this is going to be part of the lab that you guys are going to do for me at the end of this week or beginning of next week. Aluminum foil is placed into a copper-2 solution, a solution of copper-2 chloride. So let's build the equation. What's the formula for aluminum? Al. And aluminum just so happens to be positive 3. Okay, well, let's file that to the side of our brain for a second. What is copper-2 chloride? What's the formula for that? It's not CuCl.
CU2Cl?
What does that Roman numeral 2 tell you about the copper? It tells you the charge. So this is going to be Cu plus 2. Chlorine has what charge? What charge does chlorine have? Chlorine's in the top right of your periodic table. What's the charge? Okay. Thank you, Josiah. So then what is the formula for copper 2 chloride going to be? Thank you. CuCl2. So then when these guys react, aluminum is going to swap spots with what? It's going to boot out the copper. So the copper is going to go out on its own. So it's going to be Cu plus, so these two are positive. These guys are going to swap spots. How are we going to build the compound made of aluminum and chlorine? Soham already said aluminum has a charge of +3. Chlorine has a charge of -1. So we're going to have to swap and drop. You betcha. Just do it, Angel. So aluminum is going to replace the copper. It's going to make AlCl3, and copper is going to come out of that compound. Comments, questions, concerns? Okay. Then, as always, flip the page. I have 5 I want you to do. This is where things get more interesting. You have to figure out, is the singleton a positive or negative? What does it swap with? And then build the new compound properly using charges.
Where's PB? So okay, it's right.
That's the middle down. What about you?
Plus 2.
PB.
Yeah, so plus.
Okay.
PB is plus.
So 1.
You got 5. You do not have to balance. I just want you to build products.
What if nothing is booted? They're both positive. So the negative one, right?
Remember, metals on their own are just going to be the symbol. You don't need to include any subscripts. You don't need to include any charges. So in the first one, when aluminum is going to swap spots with the Pb, on its own, lead is just going to be Pb. So the Pb plus whatever compound is created from aluminum and chlorine. What's the charge on chlorine? One. So when and if this is +2, so we build it here, what's going to be? When you build this by balancing your charges, what should that formula be? And now this is that.
If you swap out a non-metal, what do you have to check for? Beware of. Beware. Beware, beware. You too. Beware. When you swap out a non-metal, what do you always have to check for? Yeah, diatomics and polyatomics. What are you talking about? I'm talking about letter D. It's not going to be NaO. What's the charge on? Okay, which one do you want to talk about? I was talking to Liam about D. Do you want to talk about B? It's not NaO. What's the charge on Na? Yeah. Which one? Yeah, that'll be MgF2. N plus Cu. Yeah. No. When you swap out a non-metal, beware. Beware of the diatomics, always. Oh, bromine is diatomic. No, because bromine is diatomic on its own. The hockey stick. No. Okay. So Josiah, when you have Cl2 plus CsBr, and these two are going to swap spots because they're both negative. So this guy's going to come out. Bromine on its own is one of the 7. So on its own, it's going to be Br2. Now when Cl takes its spot, the charge on Cs is positive 1, the charge on chlorine is negative 1, it's going to be CsCl. The last one's the same as the first 3. On NO3, it's a polyatomic ion. It's one you pick. Or is it on back? It's nitrate. Are you done? Is that why you're on the phone? Okay. It does not matter which one comes first. Well, sorry. Like this plus this or this plus this, that does not matter. Okay, so here we go. Here are your answers. What are they? Give me the first one. AlCl3 plus Pb. Very good. Letter B, what do we got? Cu plus Na2O. Very good. Third one. Cu plus Mgf2. Very good. So far, so good. Letter D. I caught a bunch of you, and I addressed it individually. When your Cl is negative, so it's going to swap with the Br. When you swap with a negatively charged object, with the 2 negative swap, you got to check for polyatomics. So it's going to be Br2 plus CsCl. And then what's letter E? Very good. Comments, questions, concerns on any of those 5? Okay, no, put your phone away. No singing. Put your phone away. I got one more to do. Last one. The double replacement. It's a little bit easier than the single replacement in that there's no guessing what swaps spots. Because a double replacement is a compound reacts with a compound. Okay, too much conversation happening at that far table, guys. Reacts with a compound. So, AB is going to react with CD. It's not hard to figure out what happens here. There's only one thing that can happen here. What's going to happen? It's going to become AD plus, it's not BC, it's CB.
The positive ion always gets listed first. So we just swapped, in this case, we just swapped the negatives. They swap spots. The gross part happens when you actually have to then go and build each of these compounds. You have to do the charge balancing, but you have to do it twice. So an example here, a solution of potassium iodide and a solution of lead 2 nitrate will react when mixed. The lead 2, you can see here, the lead 2 and the K are going to swap spots. The PB is going to go with the I, giving you PbI2, and the K is going to go with the NO3, giving you KNO3. And to build this properly, we needed to use the charges. The name tells you it's lead 2, so this is going to be Pb with a charge of +2, the K has a charge of +1, the I has a charge of -1, and the NO3 also has a charge of -1. So when you do the swapping and you do the building of the compounds, when Pb reacts with I, you're going to need to swap and drop. The 2 is going to go on the I, the 1 is going to go on the Pb, giving you PbI2. And then for the K and the NO3, the charges on those are the same. You're going to get KNO3. Positive ions can only change place with positive ions and negative with negative because the reaction still involves charge balancing. It's similar to the single replacement. It's easier in that there's no guessing what is swapping, but it's harder in that you have to do more charge building, more compound building, and you have to do it properly. Remember, when you build a compound, the positive ion comes first, and you need to balance charges. Gotta be careful when you do that. This is where the wheels came off for my D block class. They were totally great up to this point, like you guys have been. Largely, I don't think there's been a lot of confusion here. Things have been clicking for you guys. This is where the wheels came off. So when you're ready, I want you to flip the page, and then I got 5 there for you. Those 5 are your homework. When you're done those 5, call me over, I'll check them. If they're correct, you can pack up. Otherwise, I want you to work to the bell. Yes, Elijah. Sorry? Can you leave if you've already done them? No. Oh, you believe you have already done them. Okay, flip the page. I want you to do those 5. Call me over when you have something for me to check. When you're done, you can back. Let's take a look. Yes.
Plus or one? Plus or one?
Yes. Nice. Good job. Yes, sir. There we go. Which part? You were good with this stuff, yeah? This is similar. There's no guessing as to what swapping spots. This one will just swap spots every time. The CA is going to go with the OH. The NA is going to go with the S. Now to build them, you just need to build them using the correct charges. I'll get a whiteboard pen to show you what I mean. Okay, so for the first one, which one do you want to do first? The NA and the S or the CA and the OH? Okay, CA, you got OH. What's the charge on the CA? What's the charge on OH? Okay, swap drop. CA, that one. Done. Okay, so the next compound is going to be sodium sulfur. So the metal always comes first. The Na is going to come first. Charge of +1. What's the charge on sulfur? Okay. So
It's negative 1.
all this. You usually do that now for both compounds every time.
What?
It's CaOH2 plus Na2S. Yep, that's all it is.
Where's SR?
Then,
What's wrong?
did you get created the first time?
First one is CaOH2 Na2S.
Mine is NA. You wait, do you not put brackets?
Do you just use the numbers?
See, so mine.
You don't use it when you're building the compound. You only go back, you don't consider that.
Wait, it's OH
because this tree has nothing to do with how the K reacts with the alpha. That's +1, that's -1, which is going to be KI. But then if I ask you what it does, now you have to go.
You're being mysterious right now.
Okay.
Physics or math?
Yo, is PO4 negative 1?
Where do you see PO?
You're going to line.
It's negative. Positive 4.
Yeah.
I didn't know the charges.
My first tutoring gig was teaching them girls math 11 online. Online math is rough. Careful when you go multiple. Otherwise,
What does that mean? I want to give you that.
same thing. You go polynomial math, so you should practice on polynomial math. That should be.
Okay, that's good. Okay.
Oh, PO4 and then brackets.
That's not a radio.
Not OH.
Hey, let me.
Because you need two of the whole thing.
Yeah.
The same thing you do here.
I'm doing what I want with my page.
Yeah, Norris. And then I will call it. Yes.
This is girl power. Girls for girls.
Yeah, I'm gonna be.
Swear right now.
I just did that.
Yes. Good. Hang on. You bet. Yes.
It might just be a little messy.
Why is the C with AL?
Oh, oopsie.
Yeah, fix B and you're good.
Oh, I just wrote the wrong thing.
Well, and not only did you write the wrong thing, the copper is 1 and the chlorine is 1. So it should be 2. You legitimately balance copper with aluminum. Charge on silver is 1. Charge on white is 2. Otherwise, it should be AG204. Okay, all y'all may pack up if you'd like. Bill's gonna go in a second. When it does, you may go. Have a great day. I will see you tomorrow. Boom. Love it. See you later. Why are you doing math online? Arlene. Arlene, why are you doing math online?
Well, I just did like the beginning of the year with
DeVries?
Digital plus the whole.
You took the, like you did the whole semester, or is you one of the ones that dropped early?
No, I was one of the ones that
Okay. Why?
I don't know. I just like because like math's like really hard for me because
Okay.
I was in work this last year,
Oh, okay.
and like it like takes me really long to like get the concepts
Okay.
and like actually understand it. So I just wanted to like, take my time with it.
Okay. Okay. Good luck. Let me know if you need a hand.
Thank you.
Online math is brutal.